A single linked list lets you move from one element to the next, but in so doing, you immediately lose track of the previous element. It's sometimes useful to be able to move either way in a list. For example, imagine that you created a list to contain records, structures of some sort, I don't know, a list of employees or a list of books in a library or maybe the treasures in a game. And you now iterate through that list and you discover that element number 10 is a duplicate of element number 9. So you decide to delete element number 10 from the list. Think of the problem you'd have if you had a singly linked list. When you delete element 10, you break a link in the chain of pointers. Element 9 points to element 10, but when element 10 is deleted, element 9 is left with nothing to point to. You really want to rewire its pointer to the next valid element, the one that was element 11. But how do you do that? As soon as you moved to element 10 in the list, you lost track of element 9. That's because element 10 does not have any reference to any preceding elements in the list. It only has a pointer to the next element. So you can't get at element 9 to update its pointer, and the list is broken. One simple way of dealing with this problem is to create a doubly linked list. That's one that not only has a pointer to the next element, but also a pointer to the previous element. Then, when you delete element 10, you can simply rewire the list by backtracking to element 9 and setting a pointer in element 9 to point to element 11. Once that's done, you can safely delete element 10 and the integrity of the list is maintained. There are no broken links. Now let's see how you'd go about creating a doubly linked list in C.